My name is Glenn, and I work on the ASP.NET team. What I'm going to talk about is considerations for production Linux environments. So, to level set a little bit, my name is Glenn and I work on the ASP.NET team. And that means that I'm not a Linux production ops guy. Okay? So, everything I'm saying is from the point of view of somebody who started out like you and then worked here. It's not from the point of view of a guy who had to run all of your servers for the last 10 years or anything like that. It's just stuff that I've learned and considerations that and the way that we think of the way we envision how people are going to use our stuff when running on Linux. This is not going to be a particularly long segment of the talk. We're going to talk a bit about this, and then we're going to jump into the next bit of the talk I'm doing, which is Docker, and we're going to kind of refer back to this and contrast these two kind of approaches. What I'm talking about here is almost how you would set up kind of a traditional server environment, how you probably think of servers at the moment, and then we'll talk about how Docker kind of changes that story a little bit, as well as learning about Docker. So the two talks kind of fit together nicely. Some quick polling. How many of you are running ASP.NET 5 on Linux at all? Now, how many of you, of those that put their hand up, how many of you are actually using it in production or intend to use it in production, and how many are just trying it out? Yeah, sorry, which is it? How many of you are actually going to use it in production? So 2, 3, Shane, of course you are. So the rest of you were just trying it out, I guess, making sure it works. Cool, this is cool, I can kind of try Linux. Okay. Do any of you have customers or clients or your own applications that you think maybe one day in the future would go to Linux? Now, because it's possible. Okay, cool. Okay, so there's some things that you need to think about when you want to run your application on Linux that you either didn't have to think about on Windows, or they're things that you have always thought about at Windows, but it's a well-known problem on Windows. You know how to solve it. You've been doing this for the last 10 years or whatever. Okay. Every security person will tell me that this has to be the first thing that I put in this slide. Hopefully it's not earth-shatteringly revealing to any of the people in the audience. Excellent. Everybody is nodding. Okay. So, once you're not running as root, so that your web process doesn't have permissions to delete your file system, don't expose Kestrel to the internet. So Damien stole a lot of the thunder for this particular point, in that he gave most of the reasons on why you wouldn't want to expose Kestrel to the internet. He talked about using Nginx or something in front of it, or using an Apache equivalent of what the HTTP platform handler does in order to point to your running process. But it's something that what he talked about, though, is he mentioned Linux, and he mostly talked about it in the context of IIS. So on Windows, you have IIS, you have the platform handler, right? IIS is the proxy to the process that's running Kestrel that you're listening to. On Linux, you need to decide what the thing is that you're going to use to proxy all of the traffic through to Kestrel. Okay? Unlike in Windows, there's no prescriptive guidance. Pick what you want. We think that because we are Microsoft, and because a lot of the people that are going to be consuming our stuff, at least initially on Linux, are going to be people like you guys who are now coming to Linux from Windows, that we should provide you with some guidance, some given configuration of stuff that will work, that we'll be reasonably confident in. And so because of that, we'll pick Nginx, but realistically, there is no right or wrong answer. Pick the thing that fits best. There's a few categories of things. This category is proxy all your traffic. Don't put a Kestrel don't expose Kestrel to the internet. And I worded this very carefully because you could obviously make the call that my application is running well within my firewall and I don't care, and I'm just going to run raw Kestrel, right? You could decide to do that if you really wanted to. You don't need any of the, you've got your own, you control the client, your thing is inside your own network, you're just going to run Kestrel as a daemon on a Linux server, and you're going to hit it directly. You could do that if you wanted to, but you probably shouldn't expose it to the internet. And that, if you're doing what I just said inside the firewall, that's assuming you're happy not doing things like using the proxy server. Like one of the often things you will use in Nginx to offload static file servings, or SSL and an SSL endpoint, or there's many things that Nginx can do for you, so you have to be happy not using those. In the case of Linux, using static files, you end up using static file middleware, which is probably not going to be as performant as Nginx. I don't actually have any numbers for performance. I know that in IIS, static hours, I believe, no, on Windows it was okay, yeah. But there's potentially performance benefits there. I don't really know because I haven't done benchmarks yet. So you need to think about and analyze and decide what to do. This is a recurring theme in Linux guidance is choose what you want to do. Here is a category of problem that you're trying to solve, and here's 50 things that may solve it. Okay. Your application runs as a process. You have to launch the process, you have to monitor the process, and you have to keep it running. On Windows, you have IIS. IIS launches the DNX for you, the DNX process, which is running Kestrel. And it keeps it up. None of those things happen for you for free when you're running on Linux. Okay? You need to set up some way of getting your web application process to start up when the machine starts. So you need to use an initialization system. There are several, as with all the other things in this list. In the newer versions of Ubuntu and many of the newer Linux versions, they're using systemd. Our guidance, because we go back to Ubuntu 14.04 when they used a thing called Upstart, which was Ubuntu's kind of initialization system, there's going to be guidance for that. And all of these initialization systems are giving you kind of what you would get from your Windows, from a Windows process, a Windows service. You can go to Service Manager, you can click Start on Windows, you can tell it to run when Windows starts, and it'll start and it'll be running. Right? But if it crashes, it won't necessarily start back up again. Okay, so the first piece is an initialization system, systemd, upstart, run at init, something that's going to start this thing when Linux starts. Then you need something to make sure when the daemon dies, either you know about it, or it restarts it again, or both of those things, or some other combination of stuff. So that's when you need some sort of monitoring system. You need Monit, for example, is a thing you can install. You can go like apt-get install Monit, and you can configure it to watch your process or to hit a particular endpoint, a HTTP endpoint, and if that thing ever fails to respond, to do something. So in this case, you can say, run it on the same server. You can say, when you boot your DNX in your like Upstart, for example, when you run, I have an Upstart, a super basic. Now I'm showing you the rest of the points, which I'm sure are earth-shatteringly revealing. When you run, this is a really basic Upstart config, right? So one of the things in here that I do is say, start my application and drop this PID file, right? Now later on you can have, some of the things you can do is use PID files to say, watch this PID file. If anything ever happens, go and run this command again. So inside Monit, it can watch that. Or you could have it watch the HTTP endpoint, as I said, and several other ways of doing this. But the key thing is something to launch my thing when Linux starts, something to monitor my thing when Linux starts. Both of which you get from IIS if you're running on Windows, and you'll need some other thing, and it'll just be configuration. You pick the right, look at the evaluations of all of the things that are available, pick which one you like, that you think sounds good, and you do the configuration. We'll provide some set of default configuration and some considerations for you, and then away you go. This is also almost exactly the same as the guidance you would find for running Node in production. So in terms of how do you do all your comparisons and you work out which one of these things you're going to use if you want to look at it instead of just using whatever it is that we provide you, it's going to be the same. Same considerations as Node, same things as Node, same things that you care about. Because at the end of the day, running the web application on Linux is the same regardless of whether it's Node exe running the process, or DNX exe running the process, or Java exe running the process. Okay, you need to handle logs somehow. I believe that the core CLR event log type goes to systemd, like a Linux central logging system. So you could maybe do that. That's very common. All of our templates have our logging stuff to log to standard out. So Another thing you can do is when starting your application, you can send all of your standard out, like upstart. In that upstart configuration file I showed you, will pipe all of your standard out and your standard error and everything out to particular files, which can then get picked up into known locations, which whoever is running your environment or your Linux server or your ops guy can then handle. They can pull, they can do what they need to do. Some thought needs to be done to it. It might not be a very complicated process. It might just be I'm going to write everything standard out, and then I know that you Linux system admin guys know how to run processes and handle standard out. Or it might be something more complicated. Who knows? And then deployments. Chances are you're going to begin at least by FTPing stuff around again, which I don't know how many of you FTP zip files up to the server right now. Any of you? Yeah. So you'll need to pick another deployment thing to get stuff up to the server. I believe, Syed, are you doing something in Visual Studio to FTP to Linux at some point in the future? That was something we talked about once.
Yeah, we have talked about it. And I think on Wednesday I might bring up our proposed experience.
There you go. So Syed's going to talk a little bit about the proposed experience for the deployment dialog inside Visual Studio to be able to deploy to a Linux server. Maybe at some point in the future. But fundamentally, you're going to have to choose a way to get stuff onto the machine. And that's, by default, probably FTPing stuff, but maybe something else. There's lots of technologies out there, and it's another thing where you'll have to evaluate what's out there that can work on Linux and decide what you like.
Yeah, we're thinking about rsync as well. So if you have any feedback on FTP or rsync, then I think tomorrow's a good time.
So it appears that back when PowerPoint crashed, it completely broke all the images on my deck, which is somewhat annoying because I have a few cool pictures and they're all gone away. Look at that. Okay. So what we're going to talk about now is we're going to compare this, what I just described, with Docker. And I'm going to go through an overview of Docker, and I'm going to talk to a bunch of these slides, even though some of them are supposed to have big graphics on them. So how many of you have used Docker? I know there's at least some of you in here that have used it a lot. Okay, pens down. How many of you actually use it for real? Okay. And how many of you have vaguely heard about it and it's something you're interested in and know you need to look at, but you haven't done it yet? Or you've maybe played with it, right? That's kind of what I thought the expectation would be. So, first off, why do you care about Docker? Docker is growing at 18,000%. So the graphic for this particular slide was a chart from a vendor who does polling of CIOs and enterprises. And for 3 years in a row, technologies that they were investigating and starting to adopt, and Docker goes from nothing to just a massive big bar in overnight almost, from 1 year to the next. Apparently there's updates for Microsoft PowerPoint. Thank you very much. That may have helped me before you destroyed my deck. Thank you. Okay. So there's another thing here where there was a company who polls big CIOs and enterprises. This showed you the company said they have never seen adoption as fast as what this thing was going to show you. What Docker has shown. They've never seen adoption this fast in any historic technology. So let's talk about what a container is and why all these people are jumping on board so much. So the missing graphics here are the front-end VM. It just has a picture of a web space inside a container. The front-end VM, there's another tier in the middle that has another 3 containers, and then those back-end databases have containers around them as well. So what a container is, this sentence at the bottom kind of resonated with me when I read it after I'd already done a bit of stuff with Docker, and it is an isolated application environment that can be shipped from place to place. Right? I've also seen it said a structured isolated application environment, but it's a thing that contains my application and all of the dependencies of my application that I can move around and will always run, as long as there's a minimum set of dependencies on the machine. for many of you, that may sound very familiar, except for the isolated bit. It sounds remarkably like what .NET gave me with IL, right? As long as I have the .NET framework installed on my machine, I can take my .NET application and I can move it to whatever Windows server I want to run it on and it'll be fine. It was the same with the JVM. So what Docker gives you in addition to that, so I should also say that worked very, very well. Like, it was one of the great strengths and benefits that we gained from a lot of this stuff. But what you were missing from that was all the other things on my machine that made my application work, and the different versions of the .NET framework, and the in the case of running Linux and your application, the unzip library that has to be installed in order for my thing to work, right? The assembly X from company Y that has to be on the server in this particular folder in order for my application to run, right? The encryption dongle that has to be plugged into the back because of the company vendor that we're using has like crazy obfuscation software, at least which you're never going to be able to avoid if you're using that software with that vendor. But the environment was missing from that story. Okay, so the container metaphor. This slide has the obligatory shipping yard full of shipping containers that you've probably seen, which is what the left-hand side of this slide was supposed to have on it. So when talking about containers, the metaphor that Docker uses is shipping containers. It turns out that historically, shipping stuff was hard, very hard. So you have a big ship with a cargo hold and you have to fill it full of stuff. Well, it's very difficult to have standard dimensions of a ship and fill it full of TVs and computers and cars and stuff and have it actually use all available space and be efficient and make sense. And so things were slow. It was slow to load a ship. It was very custom. You needed, and if you knew how to load cars at port A, somebody at port B needed to know how to unload cars, right? And that would be different from unloading computers or unloading something else, right? So there was this industry solved this problem via shipping containers. You have a standard shipping container. It has a standard size. You fill it full of stuff. Every port in the world knows how to load and unload shipping containers. So it doesn't matter about the specialized training on each end to be able to handle this thing. They don't care about what's in it. Okay, you just have to know that there's a shipping container and you need to know how to handle shipping containers. It was easy. And this is the concept for Docker and for containers, for this type of container technology. It's make a standard thing, fill it full of stuff, and as long as you know how to run the standard thing, you'll be good. This is the goal. This is kind of the goal of Docker. This is in the end what Docker provides you. It provides you a way to put all of the stuff your application needs in a container, move it around the place, and wherever it needs to go, it will run. So you can do things like your developer. Apparently, these images are fine, according to PowerPoint. All the other ones, not so much. So as a developer, you can write code. You can write a Docker file that's going to construct an image that will later be run. I'll explain some of these terms later. You can create a container, and you can be confident that if you built a container and you gave it to somebody else that's going to run it, it's going to run and it'll work. Okay? Your ops guys know that if you're that they can move stuff around between hardware, that they can standardize a development environment. So the server environment that we talked about earlier, that was kind of like creating your artisanal small batch handcrafted server environment, right? I've got my Linux server, I've installed all the packages on it, I've lovingly crafted the configuration files, it loves my application, it runs them fantastically. However, to steal from the pets versus cattle metaphor, that server becomes your pet. It has a name, you know about it, you know how it feels in the morning when you get into work, and it's your own little thing that you have to maintain. And that works great, but it doesn't scale particularly well. As soon as you have 4 or 5 or 6 different applications with slightly different requirements, and you've got 4 or 5 or 6 of these little pet servers, then it becomes very difficult to manage. So with the cloud and with scale, you want to treat your servers like in machines that are all exactly the same. They have a number. If one of them has a problem, you get a new machine. Right? This is one of the things that we want from the cloud. If you have a standardized container format where your container can just run as long as Docker is on the machine, then you can move your containers around and it doesn't matter anymore. All the special requirements that your application needs is encapsulated inside the container. Okay, so that's why ops love it. Devs love it because they get production realism, which we'll talk about in a minute, and you also get things like test benefits. You could spin up Postgres inside of a container. You can do some queries against it and then just stop the container. And it's super fast to start, it's super fast to stop, and all the changes that you made during your integration test go away once you've stopped it. And none of them are there, it doesn't matter anymore. Okay, it works on my machine. Production realism is the key goal that lots of people want to take away as developers that you get. Given that most of you are probably developers, this seemed like an important point. Okay, so let's show some stuff. Let's use the Docker command line. So Docker works with, there's a Docker CLI, which is that Docker command that I just run. All it does is talk to a process running on some machine called the Docker daemon. Okay. So when I say Docker images, I'm talking to a particular Docker daemon, and that Docker daemon is saying these are the images I've got. In this case, I'm on OS X. The technology that containers are built upon is Linux and now becoming Windows specific. Docker daemon doesn't run on my Mac. Docker client runs on my Mac and it can connect to some machine that's running the Docker daemon. In this case, I'm using a thing called Docker machine. Docker machine is basically a virtual machine running on my Mac, a VirtualBox in this case, running the Docker daemon, and when I run Docker, it's talking to that thing. Okay? And this lists images that I've got here. I'm saying Docker images. So an image is a little file system plus metadata like the entry point for my thing, which I can then run, and when I run it, it becomes a container. Okay, and your container is an instance of your image. So you can have any single image and you can make multiple containers of it, multiple instances of it, right? So the way that this works under the covers is it uses a few technologies, one of which is a unioning file system. Zoom. Apparently I need to zoom more. More zoom. The reason I didn't zoom is because in some of the next ones, this looks really terrible if I'm zoomed too far, so I'll have to zoom back out, but that's okay. So I have a whole bunch of images on this machine that I've pulled down, various things. Some of them, for example, up the top there, you can see .NET CLI build and .NET build. They're Docker containers that you can use to build the .NET CLI that you saw demos of yesterday. So the unioning file system. Unioning file system is take a file system and then layer, effectively, other file systems, directories that contain file systems on top. And so at the end, you get a virtual file system that contains all the stuff from all the different file systems. This is fundamentally the heart of Docker. You take a base image, say Ubuntu. It's a file system and it has all of the packages that make up Ubuntu on it. Right? Then you layer your changes on top of that file system, but they're only specific to you. They're not specific to the Ubuntu base image. So I've got Ubuntu here on my machine, that bottom image there. I don't need to download that every time. If I'm running that container that's based upon Ubuntu, it's just going to use that and then layer my changes on top. Right? When I'm running a container, there's a layer on the very top of my image. So I've got an image which is my application ready to run. When I run it, I get a new layer on top, which is any change that I make inside my container only affects that new layer, which is specific to this instance of my image. Which means that if I run a container and I delete stuff, it only deletes it inside my one container. It doesn't delete it anywhere else throughout the chain of inheritance of stuff or on my base machine. So my file system is completely isolated from the rest of my machine. All right. So let's run some stuff. Let's do Docker run it. I'm going to run Ubuntu, and I've got 14.04, so I'm going to run Ubuntu 14.04, and I'm going to run bash. So -it just attaches the terminal so that I can actually type stuff here. If I didn't do IT, it would just run it like as a daemon in the background. So now I'm inside Linux. I can look around and I can do stuff, right? And I can see things running on my machine. So this is the file system that was in that Ubuntu image, and now I'm running it, and I've kind of got this layer on top of the file system, which is this container's special one. So if I now go like rm, what do I want to rm from in here? Slash? You want me to rm slash? Okay, what if I can't rm bash, otherwise I can't do one of my other demos. So let's rm date. Nope, I can't do that. Oh, I didn't CD into it. rm slash bin slash date. Now I can't run date. Right? Or I can run echo, or I could rm slash bin slash echo. I have no idea if this is going to destroy my machine. Might. Apparently it didn't do anything. So rm slash bin slash ls. Because I can't bring myself to delete star, but I'll delete ls for you. You just saw me using it and now it's not there. Okay, exit. Exit even. Apparently y is too close to t. Okay, now I'm going to run it, and I'm going to run ls. Okay, so I've got ls. Okay, what Docker does, Docker uses a bunch of underlying container technology that have been around in Linux for a while. Not super long, but it uses stuff. It's not like inventing container technology. The thing that it done that was kind of interesting is it took the concept of a Docker container being a process and made it a thing, whereas before that most people were looking at containers as kind of cheaper, better VMs, and they were thinking of them as a VM. Docker kind of thinks of a thing as a process, which is different. So when you say docker ps, this will list any containers I have running. Right now I don't have any. But if I do docker ps-a, all right, now what I'm seeing, the formatting of this is kind of unfortunate. Let me zoom out a bit. There we go. So now what you're seeing is these are the two things that I ran. All right, I've got one down the bottom called Prickly Right and one called Drunk Yonath, which are great names. These are the two containers that I ran. This is the state of my container as it was. So I can go docker start-a eb, right? I think it was EB, but I'm not sure. My machine appears to be completely broken. Look at that. Seems unfortunate. EB is the first two characters of this number here. Right? So I could have gone like prickly underscore right. Probably would have done the same thing. But it doesn't appear to matter because Docker appears to have completely died on me at the moment. So what you can do then, I could reach into either of these containers and I could run stuff. I wonder if deleting echo might have done something bad to that machine. So what you can do is then reach in and say, okay, this is the machine that I was on before. All right, I can run ls in here, presumably once things start to actually work again. But I couldn't in the other one. It was a demo that I was going to show you. Because I've got two different top layer file systems both created from the same image. Yes? Why was Ubuntu loading so fast? It wasn't doing anything. Yeah. So I have a VM that's running. It's already running. It's already started. So difference between a VM and a container. In a VM, you have the OS, and then you have a hypervisor, and then you have a guest OS, and then you have your application on top. In a container, you have the OS, and then you have a container on top. They share the kernel of the operating system. And in all of those isolation things that we're talking about with Unity file systems and things like that, they are all features of the kernel. If I go run Ubuntu again, and I say ps, I have bash and I have ps. It has process isolation. So, one second. So you share the kernel. The Ubuntu machine is already running. It's running inside VirtualBox on my machine. And when I'm saying run this container, all I'm saying is take all of these file systems that I've already got downloaded on my machine sitting there on disk, union them all together, create a new virtual one, and then start running this process in it. In this case, it was bash. And then run bash, everything is isolated, and this is the file system that this thing has. Everything is already running. No, they're not running, so no image is running. An image is just a tarball with a representation of my file system on it. When I say run, my VM is already running, so all I'm really doing is saying like hydrate this like stored snapshot and start running it for me, right? That's why it's super fast tool, partly why. Yes?
The container virtualized still very consistent, not the machine.
Yes, the container is not a machine.
That's what it is. It's just
Yeah. Yeah. Yeah, there's just one machine, one kernel, and these things are just running inside that machine. Okay? Okay. So, Docker, what was I going to do next? So, that gives you some interesting. Now, there's a Docker images I have here. I have, at the top here, I have glenc/hello web. So if I go Docker, run it again, and I say -p, I want 5004, glenc/hello web. That error message I really need to fix, but I haven't on this image. So this is running a image I've already built on my machine, which contains a compiled ASP.NET application, and it's listening on port 5004. And I need to work out what my, make sure that my IP address is still the same. So I'm just doing this, and it is the same. So if I go over here to Chrome, and I browse to this IP address, this is the application that I was just running. Now, the reason I'm going to an IP address here, it's not localhost, is because remember I'm running a VM. Docker is running inside the VM. I'm browsing to the IP address of my VM. I'm not like running this thing on my machine, right? It's isolated in that way because I'm using Docker machine. Now, you could, of course, run this thing without like attaching to it, and you could, and then it would just be running as a daemon in the background. And then you could say, hey, Docker, run this container. If it ever stops running, start it again. And the entry point that that container has is my web application, which means it's only ever going to stop if my web application process stops. Right? So then as long as Docker keeps running on the server on your infrastructure, your application is always going to keep running on your infrastructure as well. And you can move it around and it doesn't really matter. Right? Hopefully that all made some sense. So, a Docker file is your recipe for how to build your image. Okay, we have, I hope most of you got the concept of an image in a container. An image is like what your application is going to do. Your container is your instance of it. So your Docker file is a text file. It tells Docker what you want in your Docker image and what you want to run, and then this is the bottom line where it says snapshots every command for performance. See each one of these lines in this Docker file where I say from ASP.NET Beta 8, and I say add, and I say entry point. In this case, there's not really many, so it doesn't really make sense. But for most part, as you run commands inside your Docker file, what you're doing is creating more layers of that unioning file system that we talked about earlier. Which means that on your dev machine, if you build a few images, and each of them have the same intermediate layers, you reuse those, you get caching, you get perf benefits. So building your images becomes faster because you're reusing layers, you're reusing these same like stored layers of your files, of your image. When using Docker, for the most part, you replace, you don't update. Okay, you don't have an image or a container. An image in a container is not a machine. This guy up here said this earlier, and it's kind of a thing. You don't like go into your container and update the application that's running inside your container. Right? You build a new image that has your new application stored inside of it, and then you deploy it to a central place, and then you say, now run all of this and run this new image. Don't run this old one anymore. And then you just slowly turn off your old images and turn on your new turn off your old containers and run new ones. You just replace it wholesale. Infrastructure, machines are irrelevant. They're all the same. They have numbers. You don't care about them. Okay, you have an image, your image runs, and you just replace the one that's up there when you have a new one. Okay, part of what we talked about was deployments, production realism. If you build the image and you run it on your local machine, you've got a really good chance that it's going to run exactly the same way on production. Some people will build the image on their dev machine, push it to a central repository. That central repository, Docker Hub is one of these central repositories. It has images on it that you can download and then you can run. They could upload it to a central repository, then the test environment could pull from that central repository. They could run all of their tests, they could make sure it works, they could make sure it's production ready. Then the production environment can pull the same thing, or the staging environment could pull the same image. You could actually make it so the image that you are running your test against is exactly the same thing that you are running in your production environment. Right? Because all it is that base file system with a bunch of predetermined deltas sitting on top of it, which include all of your apt-get app packages that you're going to need to make your thing run, or all of your Red Hat packages, all of the source code that you've pulled in and compiled. In the case of the Beta 8 ASP.NET image, it pulls down the tarball of libuv source code, compiles it for you, and then has the binaries sitting there stored inside the image. So when you download the image, you've got a version of libuv that we built for you when we built the image and uploaded it to Docker Hub. And that's done for you, and it's always going to be the same every time you write from Microsoft/ASP.NET Beta 8. You're always going to get it, and it's going to work. Right? If we make a change to the base image, we inherit from the mono image in our mono CLR ASP.NET image. Mono made security updates in their base image. When we rebuild our image, we automatically get whatever the security updates are. When you rebuild your image, you automatically get whatever the security updates were flowing through, right? And you can set up, if you push your images to Docker Hub, you can even set up things to say, if any of the things that I depend upon change, rebuild me. So you can, if you're willing to do this, end up with a cascading thing. So you just automatically rebuild your image with anything underneath you changes. Okay? As opposed to my pet artisanal Linux server that I've manually configured. So, unfortunately, my images died on this slide as well when it crashed. So on this machine, what we had was an Nginx server at the front, and we had a bunch of ASP.NET servers at the back. But they're not servers, they're all containers. They might all be on the same server, they might all be on different servers, I don't know. I don't really care. As long as they run and they stay up and my customers can keep accessing my site. Okay? That's the sort of environment that you want to try and get towards. Now, I should also say that the picture I have painted for you makes containers and Docker to sound like the best thing in the world and that they're going to solve all problems, including world hunger. There are difficulties with using them in the real world. Docker is very, very good at a single container, a single image in a single container that you go and run in a single place. You don't use Docker itself to get a cluster of machines that I can just treat as a single resource and I throw containers at it. You need to start stepping back from, you start looking at Docker Swarm, which is not yet ready for production use according to the Docker guys, starting to look at things like Kubernetes, like Mesosphere, like there's other parts of the ecosystem that have stood up. You start to have interesting networking issues where, what if I want a container, but I want to access that container, I want to reach that container as if it was a real machine via an IP address. Right? That starts to become problematic. It starts to become difficult. There's a bunch of ecosystem things like Flannel and things like that to allow you to treat a container as if it was an image for the sake of routing, as if it was a machine for the sake of HTTP requests. And that can start to cause problems, especially once you're in a really distributed environment. But they're problems that people have been solving. The community and ecosystem is there. It's just not that you can expect Docker itself to necessarily do all of these things for you. Some of them are complicated, some of them are not complicated. They're going to keep getting better and better. But there are issues with it. If we stretch the analogy of our shipping containers further, I said shipping containers solve the problem of shipping everything for the real world on ships, right? Well, they did, but not until there were special shipping container cranes on every port in the world, right? Until there were special train carriages that would hold a shipping container and transport it on rail instead of boxcars that they had before that, right? It took a bunch of other infrastructure to change in order to make a shipping container analogy really solve the problem, and that stuff is starting to happen as well. At a minimum, you need Docker running on every machine. But there's some other stuff to help make it work. Okay, so let's talk briefly about some of what Microsoft is doing with containers. Mostly what I've talked about is Docker in general, and I've talked about Docker and Linux. You can use Docker Machine to connect. I said on my machine here, I'm running that thing called Docker Machine. Docker Machine runs a VM for you that has a machine that runs Docker. Docker Machine has providers. You can set the provider to be Azure, so that when I type Docker on my machine, it's actually talking to a machine running Docker in Azure, and then I can have containers running up there, multiple containers on my machine, right? We have Azure PowerShell and Azure Resource Manager templates, so it's very easy to say, make me a new Docker host that's running Docker daemon for me. We have the Azure CLI has a Docker image. So on my machine, I have to exit this. On my machine, one of the images you may have seen was a Azure CLI. So what I did was downloaded the Azure CLI image. I ran it. I had the Azure CLI in my container that I was running, and I'd run it with the tester terminal and I was typing. I put my credentials in there. With my credentials, save that layer to my machine, so just in my VM here. If I ever start that thing up, it's already configured to be able to communicate to Azure and run. I can type Azure and it will do its thing. If I type Docker RM, that number there, 778, this thing goes away. It's as if Azure has never been on my machine, right? Because it's never made any changes to my machine. All of the changes are encapsulated in these table that this line represents inside Docker. Okay, so interesting thing in terms of temporarily installing something and running it for a while and then deleting it from my machine. Build tools spring to mind, right? If it's tools that you need to build your application for production, but you don't necessarily need in your dev cycle. Okay, Visual Studio has Docker tooling now. So inside the web deploy dialog of Visual Studio, you can say, I'm going to deploy this ASP.NET 5 application using Docker. And then when you click go, it will communicate to Azure. It'll create 1,000 resources, or at least it seems like it. I think it's a machine and a network and a couple of things like that. It's not that big. Then it will drop you a Docker file that has been created for you that you can then edit if you want. It adds it to your solution. Then it sends your stuff to Azure. So it builds an image and it sends its image and it uploads the image to your Docker daemon running in the cloud, and then it runs it. And then it pops a browser and points you at that Azure thing that you're running. It's pretty cool. Okay, and you can do that with Windows VMs or with Linux VMs. You can choose one or the other when you are going through the dialog. You need to download the tooling. The tooling is available if you go search for it. Okay, so some of the other questions we get is, what about Windows? So Windows have two types of containers. They have Windows Server containers and they have Hyper-V containers. So Windows Server containers are basically what we've talked about for this entire session when we talked about containers. They're what you think, what we just described for the most part. Hyper-V containers provide more isolation. So one thing that many people are very quick and careful to say is that containers don't provide a security boundary. For example, inside the container you are root. Outside of the container you are root. If you manage to have an application running inside the container that breaks outside of the sandbox, it is root. And it can delete everything on your server or do anything that it feels like on your server. If I was to mount, one thing I didn't talk about was mounting volumes. Something with containers are supposed to be ephemeral. Any data that your application has should be stored outside of the container. You don't want critical application data stored in one of those layers that you're going to delete at some point when you deploy a new image, right? That needs to be offloaded somewhere else. So what Docker has is a concept of volumes, where you say mount this location, which is somewhere else, which is outside of my container. This is one of the ways to do this problem, and mount it in like /data, and then put everything inside /data, and then that'll be persisted somewhere else, and the next time you mount, it'll be there. Say I'm running Docker, and I mount you /bin, and then inside my container, I delete everything that's in /bin, well then I just deleted all of the stuff that was on my host OS, because I'm root inside the container and I have permissions to delete anything that's been mounted. right? So there is some, that was just one, that's one example, right? There are Linux kernel features coming that will solve problems like that, or at least they're attempting to solve things like that, to have user namespacing. Hyper-V containers use a hypervisor, because it turns out we already have a technology that does all of this isolation. It's called Hyper-V. So imagine your machine running with hypervisor running with something very, very tiny inside of that is running, you know, that can host containers inside of it. So you can have a single container in there, and then you're actually hypervisored away from any other containers that are running on the machine. But it's a little bit heavier because it needs a hypervisor and it needs more stuff inside the hypervisor. It needs like nano server running inside there, right? Like the really small OS. So it's basically just something we can achieve now that we've been doing nano server for a while. So let's see if this slide works. It doesn't really work because all the pictures are gone. But the intent here is to show kind of the flow that the Windows team were thinking for Docker and containers on Windows. So developers can build and test their apps. They can push them to a central repository. Operations can pull from that central repository of images. They can run the containers in the production environment, whatever it is. And then they can collaborate and we can work out what's going on and keep pushing new images and shipping containers. And of course, this flow means that the developers can keep their nasty hands off of the ops guys' precious production servers, which of course are all the same and you don't care about anymore anyway because they don't have anything interesting on them. Right? Okay, so it's all about enabling choice for the Windows containers is what we were trying to do, what the last slide that is also broken says. It's about enabling you to choose. You can have Windows containers, you can have Linux containers, you can use PowerShell to manage Windows containers, you can use Docker to have containers, and there are all of these different stories. Okay? So we want to enable you to have as broad a possible choice as possible when using container technologies to try and achieve some of the benefits that we've talked about. Okay? Cool. So I'm going to stop there. Thank you very much for listening. Hopefully it has been enlightening. If you have questions and you want to talk to me about any of the stuff that I've talked about, feel free to come and talk to me. If you have objections, feel free to come and tell me your objections. Docker, you can see the benefit that Docker tries to achieve. If we standardize on a container format, it can be shipped everywhere. The other issue is that maybe there is the common issue with standards, which is we'll create the 15th standard to fix the 14 previous competing standards. And whether or not that becomes a problem in the future for Docker, I don't know. Yeah?
What Windows OS supports Docker?
What Windows supports Docker? The newest CTPs of the latest server operating system and nano server, I believe.
Is it coming to Windows 7 anymore?
I don't think so, but I can't authoritatively say. But I don't think so. Okay, thank you very much.